Sup everyone, and welcome back to another video. Today's video is going to be on graph, but part 2. If you see my previous video, my part 1 on graph was mainly about like the basic of it, what it is, why is it important, and I showed like one example of an undirected graph where I explained what it is and I coded out. For part 2, I will be explaining what a directed graph is, and as well as include like weighted graph, before moving on to part 3, where I'm going to talk about like BFS and DFS, right? For graphs, by the way. Okay, so this video shouldn't take too long then. So and then again, once I explain that directed graph, what it is, I'll write down the code and then move on to weighted and then do the same thing, write out the code after explaining. Okay, so directed graph. If you remember, undirected graph is a graph in which like the edges do not really have like any directions. So that is like the nodes are unordered pairs in the definition of every node. A directed graph is a graph in which the edges has directions, right? And that is like the nodes are ordered pairs in the definition of every edge. If you don't know what I'm talking about, I'll show you an example. Let's take we have node A, node B, node C, and then node D, like that. This would be undirected. You can kind of see like, hey, there's no really arrows or anything, but technically when you look at this, you will kind of sort of have to like imagine that there is arrows, but it's just that this one edge has two arrows pointing it. One points at A and points at B. So that means A can go to B and that B can go back to A, like that. See that? So that's undirected. Now for our directed graph, on the other hand, let's use the same example, but this time we just have one arrow pointing at it. And it points at node B. Node B points at node C. Node A also points at node D. And then node D points at node C. And you can kind of see that this node C is not really pointing at anything. And that's perfectly fine for a directed graph. So this is okay. Why this sort of matters is that like not always is where like not every node has like a mutual relationship, you would say. For this one, it would always feel like a mutual relationship, right? Node A and node B, they're together. Node B and C are together. You know, if B needs help, C can help. If C needs help, B will obviously try to help as well. But a directed, think of it as like if I take an example, right? Let's take the college prerequisite as an example. College prerequisite for a CS class. Let's say CS 101, it's a beginning course, and you know you need to take it in order to advance to like further classes, like upper division 400 or 4000. You know, you need to take the beginning course in order to move forward. But you don't. But it's not the other way around, or like it has a mutual relationship where, oh, I have to take this upper division in order to take this class. No, that's not the case at all. So it's just a one-sided thing. When you follow someone on Instagram, for example, they don't have to follow you back. It's just you following them, and that is also a directed graph. Okay, so let me erase this. And then obviously, let me show you an example with a number, because numbers are usually easier to see. Let me draw another example, something like this. Like that, yeah? So let's write down the adjacency list. Like that. 0 points at 1 and 2, node 1, node 2. 1 points at node 3. 2 points at node 3, but the node 3 points at nothing, so none. And that's it. Now the key difference in code is that undirected adds both ways. So technically, the 2 would also have a 0 here, like that. And then the 1 has a 0 as well, like that. You know, so if it's undirected, it'll have both ways. But for this one, because it's directed, it only adds one way. And And here's another thing. Directed doesn't all you can also like go back. Directed also allows you to go back, but it's not the way how like you expect it. Um, if we take this as an example, right? Hey, let's say that the node 3 is direct. It's pointing back at 2, right? Then all you have to do is really just add the edges, like a nude edge where the node 3 is pointing at 2. So directed doesn't mean that you can never go back, right? It just means that each direction is its own edge. So if you only have, say, from node 0 to node 1, you cannot go from node 1 back to node 0 using that edge. Like you cannot use this edge specifically. But if you do add where a nude edge where node 1 goes back to 0, then yes, you can go back. But that's because you added a second directed edge, okay? So you got to keep in mind. So and this is what you would call like let's take 0 to 2. This is what you would call like a one-way only. And then 0 to 1, 2 to 3, 3 back to 2. This is what you call a two-way in a directed graph, so two separate edges. And this case behaves like a undirected connection in terms of like reachability, but conceptually like wise, it's still two directed edge. Okay, so now I'm gonna write out the code for the directed before moving on to talking about weighted graphs. Okay, so let's work on the directed graph on coding. So it's gonna be sort of like similar to undirected, except for a directed it's a lot like simpler because you're only doing one direction, right? Okay, so here what we're gonna do is we're just gonna have import Java. We have the graph, and then we're gonna add an edge, and it's for directed. Don't forget, directed graph one direction. So one direction. Okay, so and then we don't have to use integer u and v. Let's just use let's call it from and to. So kind of like a mail. You're going from here and then go to there. Okay, so get from, and then we're gonna add it to like that, and that's it. If you did the undirected, it would be from you also add another one where it's like the other way around, right? Like that. But all we're doing is just one direction. So this is all we need. Next, I'm gonna quickly write out the print because I want to see it. So we're gonna call it print graph, and for here list integer. And we'll call it JSON. There we go. Now for integer I equals 0, and then we're gonna have I being less than the adjacent size. And we're gonna do I++, like that. Yep. And then all we need to do is just print it out where I is gonna plus, and we're just gonna draw arrow. Again, like I said, this is just one direction, so you don't have to write too much. And that's it. Very quick. Now for the main, all we need to do is let's call it v, and we're gonna have 5 in there. We're gonna do list integer adjacent. That's gonna be the new array list. Then for integer I equals 0, and that this I is less than the v, I++. We're gonna basically, the adjacent is gonna add this new array list. Then after that, we go here, and then we just start adding the edges, right? Not v, but let's do 0 to 1. Boom, boom, boom. We're not gonna do a lot because I'm just trying to make it quick and easy so that this video doesn't take too long. Oh, yeah, I don't know if you guys know this, but actually, you guys don't know this, obviously, but I'm going to South Carolina soon. So I don't know how I'm going to be working there, and I don't know if I'm going to be able to upload as much videos as I can, but I'll try my best, you know? Okay, perfect. Or not, sorry. Technically, I don't need this 4. I never created 4. I'm doing the same thing as what I wrote, so I should just have it as 4. Okay, so here you can kind of see that the wait a minute. Oops. That is not what I'm supposed to have. Oh, 1 should be here, yes, but this should be a 0. Okay, if you compared this to my to the example I wrote down, this would basically show what it is. The 0 pointing at 1 and 2, and then the node 1 and node 2 are both pointing at 3, where the node 3 isn't pointing at anything. And this is just one direction. That's it. Nothing else. All right, and now we're back to talk about basically the weighted graph. Now that I've finished writing out the code. Okay, so weighted graph. Boom, 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 boom. This is where you would say that like the edges have cost. So we're no longer talking about, hey, does the where does the node points to, where, you know, or does this edge has a direction or not. This one talks about edges having cost. So now this matters because sometimes the connections aren't always equal, right? So you may see that like, hey, I'm drawing it like this, and it looks pretty symmetrical. And then you'll be like, okay, so that means all the edges are kind of the same, right? 2, 2, 2, 2, something like that. But that's not the case at all. If we take like a map, for example, and say like this is my house. So I'm gonna write A, my house, and then I have B, C, and D. B, C, D are my friend's house. From me going to friend's B house, it would take like and by the way, the edges can be anything as long as it's like a cost, right? So let's take distance, for example. It's a 3 mile to B, and then from A to C it's a 2 mile. C to D is a 5, whereas B to D is a 7, like that, right? So when it comes to maps, it can be distant, time. If it comes to like I don't know, like just a lot of the things. I can't really think of like any thought right now. So just know that the edges have like cost, basically, right? And another thing you need to know is that like hey, does that mean that like does the cost stay the same both ways? So that's not always going to be, not automatically, right? Weight is sort of like attached to a single edge, and that each direction can have its own like weight, right? Let's take, for example, let's say that this is a undirected graph. If this is an undirected weighted graph, then that means that the connection that goes both ways are going to be treated as one edge with one weight. So that means that, hey, if you go from A to B, it will be 3, and then B to A, it will also be 3. Okay? But a directed weighted graph will have our direction for each of the edges, right? Then the second edge doesn't always have to be the same as a 3, but instead it will be like from B to A, it would be a 2 instead, right? So each direction is basically separate, so weights can differ, and that means like going A to B will have a cost of 3, B to A will have a cost of 2. Now we can't a good example, right? And say like in a real world, again, let's use a house for example. Here's my house, and here is my friend's house, right? My house is A, my friend's house is B. This time we're not going to use the distance, let's use time. From my house going to friend's house, it would take up to 5 minutes. So that means A to B has a cost of 5, but from B to A, it has a cost of 2. And just by looking at it, you can kind of see why. Because I have to go uphill, while from my friend's house back down, I can just go downhill. It's a lot harder to go uphill compared to downhill. Very simple, right? Other things can be like traffic patterns. You're going to work early in the morning. 30 minutes drive, not so bad. But as you're coming home, everyone's also coming home. So if there's a traffic in the highway, the time takes longer. So that would be a great example for a directed graph, directed weighted graph. Okay. So that's basically it. Weighted graph just means that edges have cost. Oh, that's right. There's also an unweighted graph, right? An unweighted graph. This is just a graph where all the edges are treated equally, so like with no extra values like distance or cost, right? So if you look at like a normal, if we only talked about the directed graph or undirected graph, then that's technically unweighted graph too. So you would just be saying a directed unweighted graph or undirected unweighted graph, But when there is a cost on the edges, that's when you have to include the name. But technically, you don't have to include the unweighted. You can just say a directed or undirected. And then the whole point of like for graphs is you just write it out and draw it out. And then people have to like just look at it. Like if I just look at this, okay, this would be a undirected, unweighted. Hey, let's add an arrow. Okay, this is unweighted but directed. Hey, let's add a cost. Okay, now we know it's unweighted and it's a directed. Weighted, sorry, not unweighted. So directed, weighted graph with example like this. And it's not even complete, but you get the idea. Okay, that's basically it. Now I'm going to be writing out the code for the weighted one as well. Okay, now I'm on the final part where I'm just going to be writing out the code for the weighted graph. Or to be more specific, it would just be the directed weighted graph because I don't need to write the undirected since I'm just gonna have it point one direction. You can do that too, but I'm doing this to just make it quicker. Okay, so yeah, just keep in mind this is gonna be a directed weighted graph. Okay, so let me write out the line. Okay, so what we have here is static class edge. We're gonna have integer 2, integer edge. Or not edge, weight. Now this edge is going to have integer 2 and integer weight. This dot 2 is going to be equal to 2. This dot weight is going to be equal to weight. And then I'm just going to write the toString. So public string toString. Writing this is just to make it look nicer. So this is optional, by the way. I'm just doing it because, again, like I said, it looks nice. Like that. And that's it. Now let's add the edge. So for the edge, it's similar to how I did it with the directed weight. Not directed weight, sorry, directed graph. It's gonna be the same thing, except since I wrote the 2 on the edge here, I'll just be doing list, and then we're gonna just have edge. Adjacent, integer from, integer 2, and then integer weight. Afterward, adjacent, we're gonna get from, and then add the new edge. And that new edge is gonna have the 2 in the weight right there. That's it. So, like I said, because it's directed, we just have one direction. Print graph is the same thing. You just have integer I equal to 0, and then I is less than the adjacent size, and then I++. Afterward, you just print out. Now the print out is the same thing. You just have that with the arrow key, and then plus the adjacent.get I. And that's it. Am I missing something? Oh, that's right. I forgot to write this part. I'm gonna get the edge out here. Let's go. Like that. There we go. Perfect. And then for the main string, integer v equals 4. We're gonna have list, and it's just gonna be edge. Adjacent equals the new array list. Boom, boom. For I equals 0. And that the I is less than the big V, then I plus plus. We're gonna basically just add the new, or just basically gonna add the adjacent into the new array list. Boom, boom. And then that's it. And then I have the add edges out here, and print. So let's just do a quick one. We have 0 pointing at 1, and that 0 pointing at 1 has a value of 4. We have 0 pointing at 2, and that one has a value of 1. We have 1 pointing at 3, and that's going to have a value of 1. 2 pointing at 1 with a value of 2. 2 pointing at 3 with a value of 5. Something like that. Not S. Save. Run. Oh yeah, that's right. I run it a second time, but there it is. That's it. Looks about right. So for this part, you can kind of see that like, hey, 0 is pointing out a 1 and a 2, right? Now inside the parenthesis, this 0 pointing at 1 has an edge cost of 4, whereas 0 pointing at 2 has an edge cost of 1. Okay? So that's basically in a normal adjacency, right? In a normal one, you're gonna have like a 0 pointing at 1 and 2. Now this 1 and 2, and you just store like the neighbors, right? But with weight, you need 2 pieces of information per neighbor. So basically who the neighbor is, and that is the 2, as well as what the cost is, which is the weight, and that's going to be the 4. Okay, and that's why we create, and that's why I basically create the edge class. And that is it. So yeah, this is it for the video. There's nothing much else I can say really. And then for the next one, I'll be showing you the BFS and DFS version for weighted graphs. All right, thanks for watching.